Did you know that humanity has actually detonated nuclear bombs in space? It sounds like something straight out of a sci-fi blockbuster, but this really happened. The year was 1962, deep in the heart of the Cold War. While most of us think of Hiroshima and Nagasaki when we hear the words nuclear bomb, a test conducted thousands of kilometers above the Pacific Ocean arguably had just as profound an impact on the course of modern history. This event, codenamed Starfish Prime, was a wake-up call that completely redefined our understanding of nuclear warfare and the fragility of our planet's invisible shields. What exactly happened up there, and what were the consequences that still echo in our space policies today? Stick around, because this story is truly explosive. We're going to dive into the day we nuked space and the massive problems it created. To understand why the United States decided to detonate a nuke in the heavens, we have to rewind to the post-World War II era. The atomic bombings of Japan in 1945 had ushered in the nuclear age, and with it, the intense geopolitical rivalry known as the Cold War. The US and the Soviet Union were locked in a tense standoff, each racing to develop more powerful weapons and more effective ways to deliver them. The primary fear was a devastating nuclear exchange via intercontinental ballistic missiles, or ICBMs. How could you stop a missile screaming through the upper atmosphere at hypersonic speeds? This question haunted military strategists. One of the more radical ideas was to use the immense power of a nuclear explosion itself as a defensive shield. The theory was that a high-altitude detonation could release a powerful electromagnetic pulse, or EMP, frying the electronics of incoming enemy warheads and rendering them useless. It was a bold, almost desperate idea, but in the high-stakes game of nuclear chess, every possibility had to be explored. This led to a series of high-altitude nuclear tests. The Soviets were conducting their own, and the Americans needed to catch up and gather their own data. So, the US initiated Operation Fishbowl, a program designed specifically to study the effects of nuclear explosions in the upper atmosphere and near space. The main goals were twofold. Militarily, they wanted to test the anti-ballistic missile concept and understand how their own communications and missile systems would be affected by such an event. Scientifically, they were curious about the interaction between a nuclear blast and the Earth's magnetic field, including the potential creation of artificial radiation belts. The stage was set for a monumental experiment, one that would take place far from the public eye. Over the remote Johnston Atoll in the Pacific Ocean, the chosen device was a W-49 thermonuclear warhead, carried aloft by a Thor rocket, its codename, Starfish Prime. On July 9, 1962, the countdown reached 0. The Thor rocket roared to life, ascending into the night sky. It climbed to an altitude of 400 kilometers, or about 250 miles, placing it firmly in low Earth orbit, the same region where the International Space Station flies today. Then, it detonated. The yield was 1.4 megatons, roughly 100 times more powerful than the bomb dropped on Hiroshima. On the ground, observers were prepared for a spectacle. But what they witnessed was beyond anything they could have imagined. Instead of the familiar mushroom cloud, the explosion painted the sky with breathtaking, artificial auroras. Vibrant curtains of red, green, and purple light shimmered across the horizon. Visible as far away as Hawaii, over 1,400 kilometers away, and even in New Zealand. For a few surreal minutes, the Pacific night was turned into a celestial light show. But behind this beautiful display, a series of unforeseen and deeply troubling events were unfolding. The first and most immediate problem was the electromagnetic pulse. The EMP from Starfish Prime was far more powerful and widespread than scientists had predicted. In Hawaii, hundreds of miles from the detonation point, its effects were felt instantly. Streetlights went out across the entire island of Oahu. Burglar alarms started blaring inexplicably. Telephone systems and radio stations were knocked offline. Circuit breakers tripped in power stations. One report even mentioned that hundreds of garage doors began opening and closing on their own. This wasn't a minor glitch. It was a clear demonstration that a single nuclear explosion, detonated hundreds of miles away in space, could cause widespread electronic chaos on the ground. The anti-missile theory might work, but it would come at a catastrophic cost to civilian infrastructure. The test proved that an EMP could effectively be weaponized, not just against military targets, but against entire societies. The problems, however, extended far beyond the ground. The The explosion injected a massive dose of high-energy electrons into the Earth's magnetosphere, the planet's natural shield against cosmic radiation. These charged particles became trapped by the magnetic field lines, forming a new, intense, and completely artificial radiation belt around the planet. This artificial belt was vastly more potent and lasted much longer than anyone had anticipated. And this had dire consequences for everything that was, or would soon be, in orbit. At the time, the space race was just getting started. Satellites were new, fragile, and incredibly expensive pieces of technology, and they were flying directly through this new, man-made field of intense radiation. Within weeks and months, the radioactive fallout from Starfish Prime began to take its toll. The first victim was Ariel 1, the United Kingdom's very first satellite, which had been launched just a few months earlier. Its solar panels were rapidly degraded by the intense radiation, and it failed shortly after the test. But it didn't stop there. Over the next several months, at least a third of all satellites in low Earth orbiting, including Telstar 1, the pioneering American communications satellite, were either permanently damaged or destroyed by the lingering radiation from Starfish Prime. The test had effectively rendered a vast region of near-Earth space hostile to the very technology it was supposed to help protect. The US military had shot itself, and the entire burgeoning space industry, in the foot. It was a stark lesson. Our actions in space can have long-lasting, global, and devastatingly expensive consequences. Despite the shocking results of Starfish Prime, Operation Fishbowl wasn't over. In the weeks and months that followed, the US conducted 4 more high-altitude nuclear tests, though at lower altitudes and with smaller yields. These were codenamed Checkmate, Bluegill, Triple Prime, Kingfish, and Tightrope. Each test had specific scientific objectives, trying to fine-tune their understanding of EMP effects at different altitudes and how nuclear fireballs interact with the atmosphere. For example, the Kingfish test, another 400-kilometer high detonation, produced another widespread, spectacular aurora. These subsequent tests confirmed what Starfish Prime had so dramatically demonstrated. Nuclear weapons in space were incredibly disruptive and unpredictable. The data gathered was invaluable, but it painted a terrifying picture of what a real nuclear conflict involving high-altitude bursts would look like. It would not just be a battle between armies, but a war against the technological backbone of modern civilization. The alarming results of the Fishbowl tests, coupled with the escalating tensions of the Cuban Missile Crisis in October 1962, served as a powerful catalyst for international diplomacy. Both the US and the Soviet Union had now seen firsthand the chaotic and uncontrollable consequences of detonating nuclear weapons in space. They realized that using such weapons, even defensively, could cripple their own critical satellite systems for communication, navigation, and surveillance. It was a classic case of mutually assured destruction, but applied to space infrastructure. This shared vulnerability pushed the superpowers to the negotiating table. In 1963, they signed the Partial Test Ban Treaty, which prohibited all nuclear weapon tests in the atmosphere, in outer space, and underwater. It was a landmark agreement. This momentum carried forward into the definitive treaty governing our activities in the final frontier. In 1967, the Outer Space Treaty was signed. Article 4 of this treaty is one of the most important pillars of international space law. It explicitly forbids signatory nations from placing any objects carrying nuclear weapons, or any other kinds of weapons of mass destruction, in orbit around the Earth, installing them on the Moon, or any other celestial body, or stationing such weapons in outer space in any other manner. The legacy of Starfish Prime is written directly into that text. The beautiful, terrifying auroras of 1962 served as a global warning. They showed us that space is not a distant, empty void where we can act without consequence. It is a fragile, interconnected environment, and its weaponization poses an existential threat to our way of life on Earth. So, the next time you look up at the night sky, remember the story of Starfish Prime. It's a sobering reminder of how close we came to turning the heavens into a battlefield, and the critical importance of the treaties that keep it a peaceful domain for exploration and discovery. The lessons learned from that explosive experiment, 400 kilometers up, are more relevant today than ever before. As more nations and companies venture into space, we must continue to uphold these principles and work together to ensure that the final frontier remains a source of wonder and progress for all humanity, not a theater for our conflicts. Thank you so much for watching. If you found this story as fascinating as I did, please hit that like button, subscribe to the channel, and ring the notification bell so you don't miss our next dive into history's most incredible tales. Let me know in the comments what you think. Did you know we had nuked space before? Until next time, stay curious.